I don't know if that's recording. Yeah, it could be. Okay, there we go. Yeah. So it's a pure functional language, which there's actually not a lot of pure functional languages out there. The one most popular one is Haskell. The other less pure but still functional languages that you might have touched are like F# maybe, or Scala, or in the React world, they're trying to punt something called Reason ML, which is based on OCaml, which also looks really cool, but they're not necessarily pure. So what does pure mean? Pure means that in general, your code needs, like every function is deterministic. So it means given the same set of inputs, you will always get the same set of outputs. So it's like mathematically pure, if that makes sense. Whereas in a language like F# or Scala or whatever, like that's, I mean, you tend to try to write pure functions, but you know, it's pretty easy to call out to like printf or write to a file or something, which would cause a side effect and then sort of make that function impure. But it's not too important for now. It's just like an interesting thing, and we'll probably see as we try to understand PureScript, we'll see some of that stuff like hanging out, and some of the stuff that you might think, you know, like even a hello world is an interesting problem in a pure language, because a pure language technically is not really allowed to print to the console. So printing hello world sometimes is not the easiest, is not the best example of a hello world type app actually in a pure functional language. Of course you can do it, but there's normally mechanisms to allow you um, to create side effects like printing to the console, writing to a file, or querying a database or whatever. So you folks can jump in and like ask me anything. I mean, like I've got no format here other than saying, hey, like I'd love to learn some PureScript. And so I was just going to put aside a couple of hours a week. And I just thought it might be interesting to include some other people actually, because sometimes it's easier to learn stuff when there's like, when other people are learning it and you're kind of like in a like a learn teach kind of mode, right? And we can all be in that kind of mode. So fortunately for me, I do know Haskell like at a very beginner level. So like I've played a lot with Haskell a couple of years ago, probably like I think 2016 was, I almost spent about 6 months, not for any like work related stuff, but 6 months of my evenings and weekends really pouring my energy into Haskell. And I read a couple of books, and I thought at one point I knew what I was doing, and stuff just gets quite hairy in Haskell pretty quickly when you get into some of the advanced stuff. It's like it's really hairy, but like some of the and so what I'm kind of hoping with PureScript is, maybe, I know it's heavily inspired by Haskell, but it must also be heavily inspired by building real stuff, right? So it compiles to JavaScript, which is awesome. And actually, like, you know, deep down, I do believe that a pure functional language actually is quite awesome for JavaScript because of the web. So I think if you're building stuff for the web, it's really nice to build functional reactive type of architectures for user front ends, right? So it's like, for me, it's a good match. So I'm assuming that there's a whole bunch of Haskell-y stuff, and so I can like help us along, you know, with some of those concepts. So it shouldn't be. I think there's a lot of surprising stuff though that we may get through, but like keep it interactive, Oaks. Ask questions. So from a starting point, I've really done nothing other than these two lines up here. I've like installed PureScript, and I've installed something called Spargo or Spago. I don't know how to pronounce it. I think it's Spargo. And this is literally on their homepage, like how to install it. npm install -g PureScript, npm install -g Spago. So Spago or Spargo is, I suppose, like their package manager, right? So I assume it's like the difference between Node.js and npm, right? So Spago being more like the package manager, and maybe the build chain tool and stuff. And then PureScript is probably just the compiler, I assume. So I did check that these things are working, because I can go Spago and it shows stuff. And I think I can go Purs, which is the name of the compiler. So Purs is the compiler. And my assumption is we probably won't use the compiler very much. We're just going to use Spago. So I clicked on this quick start earlier, and I can see it goes through the same thing. Oh yeah, there's Pers, Spago, so CD project, and we can go Spago init. So let's just do that. I've made a directory called PureScript learn, so I'm going to go Spago init inside it, and here is that directory. Okay, cool. Okay, so check, there's new stuff, right? Different stuff. Packages. I don't know what this is, but it's something. Probably the packages that you've imported or that you want to import, and your Spago project. So this is maybe like the build recipe, and these are like the packages. But that's fine. Like I don't want to get hung up on that shit. More interestingly, let's have a look at source. So they've got source and test in the default thing. Oh, that's quite cool. What is that? I can't actually see what that is. Is it like a
tomato soup?
It's a spaghetti.
Oh.
Okay. Okay, so that's cool. Main.pers. Oh look, they log it there as well. So we can make that hello world, right? I pressed save and now I get errors. Import prelude was not found. Oh, that's interesting. Maybe I've got to build it. Spago build. Yeah, probably needs to like import packages, right? Did these go away now? Yes, they do. Cool. Okay, so Spago build. Yeah, okay, so Spago build imported a whole bunch of packages. So this is very common with like certainly a Haskell type of language that like even stuff like the plus operator is not built in until you import it, right? So probably what we'll find is like prelude. Okay, so it's cool. Haskell also calls it prelude. Prelude is like your list of millions of libraries of like your basic like common stuff in a language, right? So I wonder if we can if we can dig through the prelude. I don't know. Maybe I can control click it. Yeah, cool. So we can dig into it and we can see that it seems to like import. So with the module prelude, we get a whole bunch of stuff, probably just a whole bunch of kind of standard functions and operators that you might expect, like there's plus, right? And multiply and comparison stuff. And this is quite common. Certainly in Haskell, this is how everything happens. So even so like literally, I can have a project that is like literally tiny. It doesn't even import like a maths plus operator, which is maybe a bit different to other languages, where like where the language itself implements like plus, like that doesn't need to be implemented as a library. Whereas in Haskell and now certainly in PureScript, you'll see there's actually like an implementation for plus. Like if you can dig into this data.semiring, it's interesting, semiring, there'll be an implementation for what plus looks like how it's implemented, which is pretty cool, right? So everything in the language is built up through libraries or through modules. It seems like they're called modules, yeah. So that makes sense. And there's some other scary shit here, like the word monad. I'm sure you'll see all over the place, and monoid, semi-rings and semi-groups. Sure, I don't remember this stuff, but these are Haskell-y things as well. Yeah, rings, semi-rings, semi-groups. These are category theory related things. But like, check it out. So like data.ord. So this is talking about like ordering, I assume, like stuff that can be ordered, or ordinals, I suppose you call them. So in the data.ord package, you see stuff like less than, equal to, greater than, equal to, min and max, or clamp, between. Those are functions provided by like a module called ord. Pretty cool, right? So I think it's pretty typical that you would import prelude. That's like pretty much starter level stuff. So if we let's just look through this. So we go module main, where so we're defining a new module called main. Makes sense. That's our library. We're importing the prelude. I assume, can't remember because there's no brackets. I think that's like an import star. So it imports everything and it should just become local. So log. Oh, I see. So log probably come. Oh, there we go. So log of hello world. So main equals do log of hello world. ignore this do thing for now. Log comes from a module called effect.console. Okay, that's pretty cool. In Haskell, this would be called the IO monad. So I think in PureScript, these are called effects. Side effects are called effects. In Haskell, you call this an IO. I think you would call it an IO, yeah. And we're just importing the log function from effect.console. If we hover over log, what does it do? It says log takes a string and it returns us an effect of a unit. Okay. Yeah, I think okay, so here was my high level agenda. I think we know kind of what this program does, right? Yeah, and let's just make sure we can run it though. I think we go spago run. Hello world, yeah. Okay, good. So it works. What would be quite cool actually is to see how did the compiler, where did it put stuff? Whoa. Okay, so we got source test. Yeah, output is new. And check it out, like all those libraries are like now in output. So do we see our main? Yeah, there, main index.js. Ah, okay. So there's our compiled thing. Effect console.log hello world main equals, and then it exports it. Okay, because we've got a module main, I assume, and we're defining something called main that gets exported by main. So that means if we create a new thing like a tom equals hello or something, I'm saying I haven't declared the type, but that's fine. It can figure it out, right? And we build that. Let's just see if that gets exported. Yeah, it does. Okay, so tom equals hello, and it gets exported. Okay, so from a JavaScript perspective, that makes sense or doesn't make sense? Does anyone care?
Makes sense to me. Everything you define is exported and available. I'm just curious, how would you declare something private then?
Yeah,
It's like
it's a good
you don't
question.
want.
You know what? It could be like in the module up there. So if I want to export main, I mean, this is what I would expect in Haskell. Is I say module main, and then it's exports up there, where that maybe looks like it does it. Yeah, there. So you export what you want. You just list up at your module definition what you want exported. The same way that when you import, you list what you want imported. It's like a mirror image.
Okay,
Which
so if
makes
you leave the
sense, right?
brackets out, it makes everything public
It's a
by
star.
default. Yeah.
So it's the same as when I import, it implies the star. I think I can be explicit and I can go ... and I can probably say main ... No, unable to parse. So it doesn't like that. So I think it implies a star if you leave it out, the same way that when I import, is there a ... Oh, I thought you could import ... Okay, so you leave it out and it implies a star. Same kind of thing. So this thing is complaining. So as well as it being, so it's certainly, let me just write this. So it's definitely a pure language. So so what does pure languages mean then, Drickus?
Oh, geez, it's functional, so the input and output will always be the same, something like that, if I remember. Put me on the spot here, but I did listen.
Yeah. No. That's so absolutely. So it means given the same inputs, I'll always get the same outputs. But so what would I expect to see in a so that's 100% right. So when I'm working with a pure language, the same input will give me same output, definitely. But however, so I have a language where I mean, like it also means no side effects. No side effects. So this means you can't print, you can't write to files, you can't read files, you can't talk to the network, you can't talk to the internet, nothing, right? Because side effects are things that are like a state outside of your program, right? Either if changing the state of something outside of your program or reading the state of something outside of your program would be a side effect. So typically we would expect because obviously that's useless. That's a useless language unless it's like a totally maths type of language where there is no side effects, but generally it's pretty impractical. So it means we expect to see something that wraps up side effects in something, right? And that would normally be and we could talk about it like much later. So and that might be a monad or this effects thing that we saw, effects. Okay, so it's a pure language, cool. What was my point on this thing? What were we talking about? Oh yeah, the other thing is it's strictly typed, right? So what does strictly typed mean, Matthew? Hi, Matt.
Hello. So how to say this? So it would mean you can't just like dynamically convert string to integer because it will obviously break. So it identifies types and you can't break that typing.
Yeah, exactly. And it's compiler checked, right? So Drickus is a Python guy. So in Python you can do this. You can do this, right? Tom equals hello, right? In Python, no problem. But in Python I could also say Tom, like right after this, I could also say Tom equals 5. And Python would say, yeah, that's cool. Like from a typing perspective, the compiler cannot check this for you in Python. Maybe you could get a linter or something that could check this for you. Some static analysis tool could check that. It's like saying, hey, but wait a minute, like Tom was always a string and now you're making it equal to 5. Like Python can't check this. It can only run this at runtime, right? Or if you had to in Python go like print something that's like unprintable, like print, what would be a good example? Print null, or I don't know. I think Python would just deal with it, right? Because it just duck types it. But like some things you can't do, like x equals 5 plus dog, right? That like just doesn't make any sense. In Python, it would like the compiler go, there's no compiler. So it hits this line. And at that point, while the program's running, it'll go, but wait a minute. You can't add an int to a string. Like that's bullshit. Whereas in a strictly typed language, and this includes C# and Java and any language that is strictly typed and has a compiler, it would tell us quite clearly that it's like a string, like the plus requires an int or something on the left and an int on the right, and it's saying here like that's a string. So that's a problem. So it's strictly typed, but interestingly, it can infer types. So don't confuse those things. So it's strictly typed, but also what would you call it? Implicitly typed. Implicitly typed. Does that make sense? So I can say, hey, x equals dog, and it says, yeah, cool, x is a string. I never had to tell it that it's a string, right? I could, of course, say x is a string. And then it's like, oh, cool. Like, that's fine. But I didn't need to do this. This is kind of, it's optional, and it's probably good practice a lot of the time. But it means the compiler is smart enough that I don't need to do this. Does that kind of make sense? I suppose in like C#, you've got that cool var keyword, var x equals 5, right? And that tells the compiler, hey, like make up your own. Please, could you implicitly? I'm implicitly typing x, so the compiler must figure out what is x, right? Whereas prior to that in C# and certainly in Java, you still have to say int, or int lowercase I probably. Int x equals 5 in Java. You have to tell the compiler, oh, this is an int and it's equal to 5. Do you know what I mean? So that would be more explicitly typed, an explicitly typed language, right? It's just interesting to separate those. Pure, strictly typed, but it's implicit. Can be implicitly typed. All right, so we did hello world. Oh yeah, so these are just some notes I took. I think we must, yes, how's it?
I just wanted to say something about the pure language.
Yeah.
I always thought it's also about something like F#. It's not pure functional. You can break out of, you can like force something to be mutable. So you can use it in a non-functional way. It's not, and Haskell, it's impossible to write non-functional code. Isn't that also something about pure?
Yes, yeah. I think we talked about it before you joined, but yeah, 100%. So that's exactly it. So like you actually you're talking about immutable, right? Immutable data structures, and that's an absolute, like if it's a pure language, this is a guarantee that data structures are immutable, because it's not possible if a pure language says given like a 1, I always return a 2. There's absolutely nothing else that can happen. Will never return a 3. Cannot be. So like, for example, so even stuff like random, is difficult in a pure language, because random is like not pure. Does that make sense? That means like, so if I define a function, I'll write it in here. It's not going to compile, but if I say, hey, I got a function, and it, I'll write it in C# or whatever, return, I don't know how you do this in C#, random.rand int or something, right? And this thing returns an integer. This is not possible in a, well, like when I say not possible, I mean it's not possible in this way to do it in a pure language, because this implies that f doesn't always return the same thing. Do you know what I mean? So maybe it was like f given an x or whatever, and you say random times x, fine. So like given the same x, so that means if I call f with 1, this must always return whatever, something. It must, every single time I invoke f of 1, I expect to get the same result every single time, right? Whereas here you can quite clearly see that that's like not the case. This is going to generate a new random integer multiplied by x. That's going to return me a different value for 1 every time. Does that kind of make sense?
Yep.
Anyone,
Yep.
the rest of you guys understand this?
Just a question, sorry,
Yeah.
from my side. Is
go.
the way I'm understanding this, like if it has to always return the same input. So if I equate that to link, right? So
Yeah.
if I've got a sequence and I pass in some some filter, and the filter and the sequence is not the same, or something like that.
Yeah.
I suppose that breaks it. That must always return the same thing, because the sequence, the filter may not match anything in the sequence. Does it mean that it's not pure? Because
No. So given the same sequence, the identical
given the same
sequence,
okay.
you must return the same output, right?
Same
Yeah.
output.
So that's a very good point. I mean, we can do that. So let's actually, let's actually, I think that's a great one, a great example. How do we create a list? This is the first question. PureScript. Do we want a list or an array? I think we want a list, right? Data.list. That sounds good. Sorry, I'm just Googling now, and this is maybe not the best place to look. Oh, range. Okay, so this might be a good one, right? Let's see if we can do that. So we want to call, so let's create a new list. I'll call it X. We're going to go range, probably my compiler. And so, okay, so here's something we need to look at. Is anyone comfortable with this notation for defining for what a function signature looks like?
It
Anyone
takes a bit
uncomfortable
of
with
parsing
this?
on my side, but comfortable enough so far.
So describe it, Miguel, how you read this.
So if I read that the function takes in an int, and it gives you back a function that takes in an int that gives you back a list of int.
Oh, good. Yeah.
So it's just a bit of a mental pass, because the syntax
Yes.
is not 100% to what I'm used to, but
Yes.
it's close enough to say link, or because of the arrow syntax, right? Link or
Yes.
fat arrow in JavaScript. Like, stupid name.
100%. Yeah. So actually, it's worth, even if you don't write functional stuff or use PureScript or Haskell, this is a very common format for defining function signatures. This tells you a whole lot about a function, and it's definitely worth getting used to this notation. You can even use, I mean, this is, for me, this is the best way of defining what a function does. So say, for example, so let's describe range actually. So if we just put that in here, the way we can use range is, so Miguel said range, so this, the colon means like type. So we're giving it a type. So even though it's a function, in a functional language, a function is a first-class citizen, so it has a type. So we're saying the thing called range is of type. That's what that means. And so this is the type definition, right? It's saying is of type this, right? So whereas previously I could have said, hey, like my age is of type int, and my age is equal to 5. These things are totally equivalent. It's just when you read this one, you go, oh yeah, but this one's like is like a function, you know what I mean? But it's really from a, whether it's a like a value, I'm avoiding the word variable, but like in your mind you could think that my age is like a variable. just it isn't, because you can't vary it. So you'd call it a value. Range is also a thing. It's not necessarily a value though. It's a function that, given an int, will return you. So it gets, and Miguel described it perfectly, but effectively the way you would break this down is it would say range is of type, and you can see it's an int. So types must always kind of be like, functions are always something to another thing. This extra arrow thing here is like is like not supported. So a thing to another thing means that it's like, okay, it's a thing to this thing. Do you know what I mean? And it turns out that that thing on that side is, oh, look, it's also a function. Does that make sense? So once you bracket it, you can kind of start to decode it. And you can say, oh, the thing on this side is a list int. Does that make sense? So it's like range actually only takes one parameter, int. It takes a thing of an int. What does it return? It returns this thing. What is this thing? It's another function which takes an int. And what does it return? It returns us a list of int. Does that make sense? Who doesn't understand this?
So, Tom, I watched a video about PureScript the other day, and I think it makes sense now. I understood it as it's two input things. So the first int and the second int are both inputs. And then the list int is the output of that function.
Yeah,
that was my understanding.
Yeah, totally. And that's the way to summarize it. Absolutely, because it actually is, right? However, when we decode it, it's kind of the same. We could write this in JavaScript. Let's do that actually. So we go, range is a function. Should I use the word function or should I use arrows? What do you guys prefer? Function. Function. Taking an x. So like this is how you would normally do a range. This is if it was totally naive, if it was Drickus's definition, where it's like we want something that goes range, and I go 1, 3, and that must return like whatever 1, 2, 3, right? I don't know how range works, but I assume it's like inclusive. It's probably exclusive anyway, whatever. Like that's what we want, right? If we had to write this in JavaScript, we would say range equals function x comma let's go x comma y, and we would return whatever stuff. Return an array with x dot y, however that is implemented, right? In a for loop or something, right? You happy with that's how you would define it in JavaScript, right? There's another way of defining this, and this would be the more functional way, which would be range equals function that given an x, we would return a function that given a y would return the x dot y. This would also be totally valid, right? So the way we would call this, top one, we would say range 1, 2. The way we would call the bottom one would be range 1. Is that crazy? Or not crazy?
Slightly net.
No, that explanation makes
is it
sense to me.
composing functions, right? I mean, that's what it is.
Well, it wouldn't call it composing. So this whole notion is called currying, right? Currying. So this version is the curried version of this. Because and actually they're totally interchangeable, right? They're identical from a functionality perspective. They both do exactly what we expect. Like the x here is in scope. The y is in scope. It's just that the x came into scope earlier. Do you know what I mean? So you would call, in JavaScript, this is called a closure, that x is enclosed inside this new function down below, right? But this concept in languages is called currying. So they're and it's just something like it's a cool thing to do. That like if we had the constraint that we just constraining ourselves to say every function out there must take only one input. You can't have a function that takes 2 inputs. And that's an okay constraint because we know that with currying we can create functions that feel like they take more than one input. Does that make sense? And so this notation is how you would think about that. Like you can of course make a function in a functional language. So say in PureScript, I'm not sure how you do this in PureScript, but you would say, if you wanted it, like every time it must take 2 parameters, you would say, that's fine. I'll take a tuple of 2 and I return a list of int. Do you know what I mean? And that would force the caller of this version of range to specify range 1, 2. Do you know what I mean? So then it feels more like a function execution in the old school function execution. Does that make sense? So these are different. They practically come out with the same end result, right?
So Tom, just to help, could you show us how you would call that first range function?
Yeah.
With just one parameter. So say you want to do range and you know your lower limit's always going to be 0. So you called it with 0 and maybe set that to another value. Just show us what the benefit is, how you can call this with only one parameter and then later.
Yeah, right. Yeah. So that would be called partial function application, right? Partial function or partially applied functions or something. So with this cool version here, so if we look at this cool version, the downside is that we always need x and y at the same time. Agree? Like we can't call this function if we don't know y. Or x. Like we always need it, right? We need to know that 1 and 2, like they are fixed. Whereas with this version down here, the upside is we could call range 1 all by itself. So we could say like range starting with 1 equals range of 1. And then later somewhere else, we could say, oh, we want to execute that with the y parameter now that we want over there. So there could be like a time gap in between the 2 executions of this. So here's where I've got x, and here's where I've got y. I've managed to separate them in time and space.
Yeah. Or you can call range starting with 1 multiple times. Now, because
range starting with 1, range starting with 1 again. Yeah, and I never need to know about x again because it's like it's captured inside this new function. Does that kind of make sense?
Yeah, that helped me the first time I looked at this because it showed you why this is better. Why would you want to constrain functions with only one parameter? Because you can do partial application.
It's actually not like this is not something. This is one of these things you would take for granted one day when you start. When like you'll see it in other areas where you'll go, oh yeah, this is only really doable because of this. Like if I didn't have this, this would constrain me. But it's not like maybe entirely clear right now why this is amazing. But and it's not that amazing actually. It's just it's a small little detail that like unhinges like a whole bunch of new stuff that potentially quite cool. So when you see other example, like actually we're going to see it now. Our example, or Terence's example, where he had the range of things that he wanted to filter. Let's go do that because I think that's where this rabbit hole began. And we'll see how function application maybe comes in. Okay, so we know that range looks like that. Oh yeah, we're just looking at this doc. So I'm going to kill this thing. So can I execute range? Oh yeah, so another very interesting that you probably will hate initially is when I call range, I don't need to give it brackets, right? Because it's like obvious. Like range takes one, like the first parameter is that one, the second parameter is that one, right? And because remember I can do the separation of time and space, like the compiler doesn't need you to bracket these things for it. There's no need. So you can, in fact, you can't bracket these things. So to execute range, I could do this x1, so x equals 1, 2. I'm sure this thing's going to complain. It doesn't know what range is, and it's because we need to import it. So let's import it from this, and I'm just taking a guess that we go import that, and we want to import range. Ooh, and it doesn't like that. Oh yes, because there is a module that our compiler requires. So look at this package thing here, PureScript lists. This is common, so it's like, yeah, this functionality, like lists, is not part of my runtime probably. So if I look in my compile stuff, I don't see data.list here. So I need to, because it wasn't part of Prelude, right? So I probably need to pull it in from a package perspective. This is like probably a Spago thing, Spago install package. Yeah, let's just Google it. This should be, how do we do it? Let's just look at Spago. Spago minus help.
Spago install and the package name, similar to npm. I don't think it has the shorthand of either.
Okay, so would it be that name there, PureScript?
Yeah, no, that's what I did now. Sorry, I'm typing and following along as we go along.
Done. Look at that. So we installed the package, press save. Does it go away? No, it's still there. Oh, we probably have to build it because that would pull in these packages. Yeah, the data.list is now there. Great. Now there's some other error. No error. Oh, it's a warning saying you haven't told me the type. That's fine. So can I hover over X now? Yes, and it says it's a list of int. So that's cool. We may get into why there's a list space int there, but maybe not. So let's just fix that little warning and just say, yeah, it is a list of int. Doesn't know what a list is. Unknown type list, probably because we need to import list up there. Yeah, okay, so now X is a range of 1, 2. I wonder if we could print this actually. Let's try list, and we're gonna go, how do we log? We probably want to like plus it onto a string, plus X. I don't know. Doesn't know about plus. Unknown operator. So how do we string concat in PureScript? Let's Google it. String concat. Have abandoned plus in favor of. Oh, that's interesting. A little not equal then. Okay. And then now our error says could not match type list with type effect. Oh, fuck. So I know how I do this. So the problem is with log is trying to take this XX thing. You know how we could maybe solve this is like, rather than like printing shit is hard until you understand effects, which means understanding monads, which means understanding almost everything in the language. So maybe we can do this in the
funny. So functional languages are always like printing. Get you
printing
into
is
all
like,
the things.
It's a very hard thing. So let's see if we can do this in the REPL, because then we can talk about stuff. I saw that we can REPL. So can I print X here? Doesn't know what X is. Type. I did see that you can go colon and you can tab stuff. Type of X. Oh, you know what? We probably need to import main. Yes. Okay. And now can we say X? Yes. Oh, cool. Okay. Yeah. Look at that, guys. What does this mean? Isn't X like a list of two things? So if I go, so can I go X equals range 1, 10? Unknown value range. Oh yeah, okay. So I need to import data.list range. And now if I go range 1, 10, check at that. What does that mean? Does anyone know? This obviously is a list, right? But why does it have that at the end?
I'm assuming the null's trying to like represent the same thing as like what you're showing us with C, the null terminator at the end of something. But
right,
I don't know. That's just a pure guess.
Yeah. I think it is that. So it's like, I mean, this is unsurprising in a functional language that a list is typically a linked list, and a linked list is something that just the one element points to the next element, and the next element points to the next element until you hit some kind of sentinel value, which tells you that's the end of the list, right? And so maybe like in C you would have pointers or something, but like in a functional language you would assume that this is probably a recursive data structure, that the start of this list is a 1, and it I mean, we can get into like how you would define a list. Maybe we should, but I think for now let's just assume that it's like a null terminated type of thing. It's probably not, and it's probably more recursive. So it's like we've got an element and an element can have two different types. Either it has a value and it has a tail. So it has a head and a tail. The head is the element, like the value in that list at that position, and the tail is another list which contains like whatever the hell, right? And you'll probably find that an element containing a nil kind of tells you that that's the end of the list, if that makes sense. We can actually even ourselves define this once we get good at PureScript, and it will teach us a lot around how to build recursive data structures. But let's just be comfortable with that for now. Okay, so say maybe we wanted to, let's carry on with Terrence's. Yeah.
Can I ask a question quickly?
Yeah.
I'm just wondering, like, what would be the point of implementing it like such a complex data structure than just, say, an array, for argument's sake? What's the benefit of having this linked list with a pointer to the next object type data structure?
Who wants to answer that? Why would you choose an array over a list or a list over an array? What is the difference? I'm going to choose Terrence. Okay, Migs, go for it.
So I was just, I don't think it answers 100%, but
yeah,
I think like an array is where you're more like memory constrained because everything is packed together in an array, where in like a linked list, they can be in different places in memory because essentially it's just pointers to those places. So it's like one is stored in index 1 of your memory band, but then like 2 is stored in 9. But that's, I don't know if that's correct.
That makes sense.
So like a distributed memory utilization instead of like a block of memory.
Yeah, because array has to be a chain of memory. Well, at least in C#, that's how it's implemented. It's a chain of memory. So like just shifting one memory bit across gets you the next index in your array, where in a linked list in C#, it can be anywhere in your memory, and it's just pointers to that piece of memory.
Yeah. So, okay, so that's one of the, that's certainly one thing, and we can talk about that. Anything else? Nothing. So so Miguel is 100% right that an array is typically, so I would use the word contiguous. I don't know whether that's the right word, but what that means is like the elements of this array from a memory perspective are all right next to each other. And so there's benefits to that. So first of all, if it's contiguous, what that means is I can perform random access to that thing. So that means and so the word random is weird, but like random access means that I can, in a structure that's contiguous, I don't need, if I want to find the 5th one, I can literally calculate where in space it is, and I can just go straight to it. Do you know what I mean? Because remember, arrays are always objects or structures of the same type. So every element is of the same type. That means I can calculate how big they are. So say it's an array of ints, right? An int we know is a 32-bit thing. Let's assume arrays are 32-bit. Well, they generally are. An int is a 32-bit thing. So if I've got an array of ints and I want to find the 50th one, I just have to say, oh, it's at memory position 50 times 32 bits, and I just jump straight there and I can read the value, right? So that means random access means I can jump into the structure at any point and randomly. I can jump anywhere and I can read a value and it will be the correct value, right? So that's what, so a good thing about contiguous means I can do that. I can do random access. A linked list is not contiguous. So that means the first element holds its value, but it also points to the next one. And the next one points to the next one, and the next one points to the next one. And they may not be contiguous, right? They could be all over, they like more like a little funny structure like that, right? So that means I can't do random access. It means I can't just jump into the 50th one. It means I have to walk through from the first one to the second, to the third, to the fourth, to the fifth, to the sixth, to the seventh. So it means I have 50 operations to get to the 50th one. Does that make sense?
Yeah, makes sense.
Yeah, makes sense.
Okay, so that's an advantage of an array. The disadvantage of an array is it needs to be a fixed size. Like I can't make an array bigger because it's a contiguous structure. I also can't insert elements into the middle of it because that fucks it up. Because like if I insert a new element into position 50, like what about the guy who's already at position 50? Like I have to overwrite him. So that means I have to, if I want to insert into it randomly, I have to like reshuffle the whole data structure. So if I want to put an element in position 50, that's fine. I have to literally take from what's there already at 50 to 100 and shift it out making me a space to put it in. So inserting into an array sucks. It's really good for reading randomly. I can randomly read whatever I want, but to insert into it is difficult. It means I have to what would you call it? Like defragment the array. I have to copy it to a new array with the new element into position. So that's like that's the downside of an array. It's also I can't just add to the end of it either, because like I have to do the same thing. So to add to the end of an array, I have to copy it to I have to create a new piece of memory somewhere which is the same size as the array plus one, write the old array into that position and add my new element. Does that make sense? So inserting into it is hard. Whereas with a linked list, it's quite easy. I've just got to find the element. So I have to get to that 50th element, and all I do is I just create a new element somewhere else. I point the 50th one to the new one, and the new one points to the tail of the old one. Do you know what I mean? So I can very easily insert into a linked list. It's also completely dynamic, so there's no size constraints to a linked list. I can continuously add to it without there being a lot of memory churn. I never need to recopy the entire structure again. Do you know what I mean? So it's in place, but it sucks that I have to I have to traverse through the whole thing to read it. Does that kind of make sense? But so it depends. So it's not to say arrays and lists are good and bad. It's like it depends on your context. You have to look at it and say, okay, this thing that I'm doing, I've got a list of users or something that I read from the database. Oh, check. I'm always going to read them from the beginning to the end. That's cool. Like an array is going to give me no advantage. A list would be fine because lists are efficient at scanning from start to end, whereas arrays are also efficient, but like I can't insert to the end and all that kind of stuff. Does that sort of make sense? So it's just a data structure. I mean, it's got nothing to do with functional language. This is, I mean, in any language, there's typically a difference between a linked list and an array, and they both suffer from this. It could be that in like some languages try to hide this a little bit more from you, right? So like in Python, when you do x equals 1, 2, 3, and you go, hey, like x, I don't know how you would do this in Python, but you go like x 3, which is like a new one or something, equals 5, equals 6 or whatever. The Python, and this is like appending or something. Actually, I don't think Python has. Do they use arrays? I don't know. They probably use a combination of arrays and lists to give them this cool like Python list structure. So anyway, the runtime is going to hide a lot of that stuff from you. In a functional language, typically like the data structures are very close to your problem domain. So it doesn't hide a whole lot from you. So when you see stuff like this, it's like, yeah, you expect to see this actually, because a lot of your solutioning will deal with this kind of structure. Anyway, does that kind of answer your question?
Yeah, that's perfect. Thanks. Sorry for the
all good. Yeah,
the
you must
tangent.
jump. Yeah. No, it's cool. So should we get back to Terence's? So Terence said he wanted to like filter stuff in his range. So let's do that actually. I think this is a cool thing to try. Is like, so we've got a list of ints. Is this range 1,10 or 110? Can we filter it? So maybe we can filter it for like, what do we do? Oh, like even numbers, right? We want to find all the even numbers in this list, right? That makes sense, yeah? So we could say like evens equals X. And now we want to be able to filter. So let's figure out how to do that. I imagine, actually, let's just Google it. This could be in our prelude. I think we saw it in our prelude. Could be data.filterable. Let's just have a look. Did we not have a filter method in here? No, check it out. Okay, so we do need data.filterable. Interesting. Filter arrays, data.filterable represents a data structure, can be partitioned or filtered. Oh, filter map, maybe a bool. Filter for all A. Oh, an F of A. Okay, yes. So this is like functor type stuff. I'm trying to avoid going into hairy land here with functors. But let's try this. So there's a new package here. I wonder, can we not just go, what is type of filter? We don't have a filter method. That is pretty weird.
It looks like there is a filter in the data.list package.
Oh, good point. Yes. Okay. Data.list. Yes, of course. Okay. So let's have a look at that. Okay, look, yeah. So check how cool this is, right? When we just search for the word filter here. Now, just by looking at this function signature, you can start to see like which one you want, actually. This is really cool. Now, this is what I enjoyed about Haskell. Haskell had something called package, I think, where you could literally do function level searches. So you could say like, hey, I want a method which takes a list of A's and returns me a list of A's. Like you could search against a signature and it would be able to return you things that match that. So it's like, oh, okay, so there's this you can kind of do this. Maybe I need the capital L. Like you could do signature level searches. Yeah, there we go. So look, there's a function called cycle, which takes a list of A and returns me a list of A, or init. And like already you can start to see like, oh yeah, so like what would the definition for filter look like? And I mean, this might sound weird, but like filter probably is something which we probably give it a list. Let's say it's a list of int. That's fine. And remember, when we're filtering stuff, we normally pass it a function to that it must execute, that must return a Boolean as to whether that element should be filtered or not, right? So the function is probably an int, right? So given a function that takes an int, when I execute this function, it must return a Boolean, right? Does that make sense? And the end result of the filter is like, again, a list of ints. Should I do that again?
Maybe I read that differently as well.
Okay.
That might just...
Yeah. So let me break that down a little bit. So if I'm going to call filter on my x, there it is. So x is already a list of int, right? We know that about x. X is of type list int. So that would be the first parameter to the filter function, right? Comfortable with that?
Yeah, it's the next part, because just maybe for context from your side, I'm reading that again because of how we read the previous one. Again, it's the syntax that's maybe the problem for me.
Yes. Fine.
List that gets a function that returns a function.
No, that's perfect. So
that passes a list.
If we remember that this is kind of, I'm just going to make this simple. That's the first parameter to the function. That's the second parameter to the function. And this is what the function returns, right? This was Drickus's summary, which was absolutely correct, right? That's the first parameter, list of int. Second parameter is this thing, int to a bool. And that's because when we filter something, we give it a function to say, well, what do we want to filter? So given an element, so like I kind of expect to do it like this, but it could be in JavaScript. I would say, well, given an e, if e mod 2 equals 0, right? That would find my even numbers. So that would say, so filter is going to run through the list of ints, and for every int, it's going to execute this function to say, here you go. And you're going to return, sorry, I could make this more terse, return, that element modulus 2. If that's 0, that's an even number, right? So that would be true or false. So this function returns true or false. Happy with that?
Yep.
And it returns an int list. So this means I can say, oh, cool. So like result equals that. Kind of happy with that? That makes sense?
Yeah, that makes more sense to me now.
Yeah. So when we define filter, and I'm not saying this is how filter looks, not just yet. That's like maybe the function signature we're looking for, right? The interesting thing here is from a filter perspective, like this int and this int and this int are actually arb. They're not important because filter itself doesn't give a shit about, as long as it's a list of somethings and the function that you pass me here takes a something to a Boolean, I will return you that list of somethings back, right? So this int, so in this scenario, I can say, oh, actually, this could be, it's kind of like a generic, right? It could be a generic type. It could be like type T. It could be a list of T, given a function that's given one of those elements of that type T. As long as it returns a Boolean, I can give you back a list of type T. Make sense? Yeah.
Makes sense.
Because I could filter a list of ints. I could also filter a list of strings or a list of chars or a list of dates or whatever, right? So, and the filter function doesn't care about what is inside those lists. Do you know what I mean? It's just going to say for every element, for each element, execute this function. And as long as that function, that parameter in that function is the same type as that one, it will work, because filter only cares about the Boolean. And it will always return you back that function. So in Haskell and in PureScript, you typically, so maybe in C# and Java, you might use like type capital T when you're defining this generically. So you could call this kind of generics. It is the wrong word. You would just say, you would use a lowercase letter and you would say it's of type A. And the lowercase a tells you it's a type, but it's not a specific type. It's a type of type. Do you know what I mean? So we could probably use this actually. So if we look at the signature, I could probably search for this. I reckon filter would come back. Oh, please work. Come on, give me filter. Filter? Bastard. I don't know why. This is a crappy search. So let's find the data.list one that Matt found. Was it data.list filter? I wonder if I can search for that up there. No. Filter. Oh, we had it here. So there was one with array. And you can see it. Look, it's in the data.array. We're not working with an array, we're working with a list. So it's this one. Oh, look here. Oh, they've just got their parameters switched the other way around, which of course we could do as well. So that's why my search didn't work. So it was like, oh, they actually take the function first, then the list second, and that returns the new list. Are you happy with that? So that means this X just goes there. Sorry, it was just the parameter ordering. Yeah. So now actually maybe our search, if we look at this pursuit thingy, maybe our search would find filter now. Yeah, it does. Oh, how cool is that, right? And you can even see that it's like, oh, there's other things that match the signature. So it's like, yes, filter for sure, but also like drop while. And it's like, oh, drop while is also something which has a very similar signature to filter, but it behaves slightly differently. So this is like keep dropping while this thing is true, and then as soon as that's false, then everything else would be not dropped, right? Does that make sense? So it's kind of like a filter, but it's a filter which remembers it only will switch from true to false once. Does that make sense? So drop while, list. Looks like they maybe, oh, look, there's a data.list, data.list.lazy. This is another difference between PureScript and Haskell. I think PureScript is not lazy. Not too important. Filter makes sense. Take while is the opposite of drop while. So it kind of makes sense. Like I can search on signatures. Isn't that cool, actually? That's so cool. All right. So let's just do it. So we've got this cool little definition. I'm not going to define that one because we're going to import it from data.list filter, right? And we're going to call filter. This is JavaScript. We can't do that. I think in PureScript, it's similar syntax, except we don't use a bracket, we use a backslash at the beginning. And I think we will use an arrow, and I assume there's definitely no return keyword. If I save that, does that work? Yes, except it doesn't like modulo. So just quickly on this backslash thing, the idea of this is, because it does look a bit weird, and you would say, well, what if this thing took more than one parameter? So this is effectively an anonymous function definition, right? Exactly like a JavaScript arrow kind of function, right? The backslash, though, just from a syntax perspective, is the start. Is effectively, it's meant to look like a lambda. Do you know what I mean? You know the old lambda element, lambda symbol. That symbol, that thing, that's what that backslash is trying to look like. And then it kind of makes sense because, like in Python, you would have, you have actually a keyword called lambda x y or something. I can't remember. So it's effectively a lambda. If it was taking another parameter, you would go e space y, and that would take. So that's the first parameter, second parameter. Does that kind of make sense? I can see we are out of time.
Yep, I think it's just Bhavesh and I left. I think everyone had to drop off.
So maybe we must stop there.
I think so.
Yeah, awesome. Any last questions? Yeah.
I missed the middle bit, but this looks pretty cool at the moment. I wonder why the modulo is not working though.
It's probably because things like this are not just built-ins. So Prelude, actually, maybe it does have a module. It might just be a function called mod. Yeah, there we go. Euclidean ring degree div mod. I don't remember my. Oof. Maybe let's just try the word mod. So here's going to be something interesting. So you know the difference between infix and postfix, or no?
I did at some point.
Yeah, you did at some point. Yeah. So like the plus operator is infix, right? This means I can put infix means it sits between its parameters. So it's like the first parameter to plus, and like you can think of plus as a function, right? I mean, plus is a function that takes two parameters, the first one and the second one, and it returns like the addition of the, whatever the fuck addition actually does. So you can kind of define plus as a function like this, a function that takes. So in most languages, you can't just define it raw. You would, if you're defining an operator like a funny symbol character, non-alphabetic, non-A to Z type of thing, you would normally bracket it just to tell the compiler, listen, like, don't confuse this. You can literally define plus like this, or you could even define a new one like plus 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 x and y equals actually, x plus y. Right, and this actually should compile like no problem. So I've just defined a new function. Have I? Oh, it's not happy. Unexpected token. Doesn't like it. Fuck. I thought I could. Can I not? Maybe I have to say.
Maybe it's not brackets. That
Is of
distinguishes
type
it.
int to int to int. Oh, why can't I define that? I can in Haskell, I'm pretty sure. PureScript symbol function or something like that. There will be rules around this thing. Let's say PureScript define operator. I mean, that might be a basic way to search for it. Syntax, let's see. There's bool sort one is empty. That's a number. Some regex thing. Property access makes sense. Binary operators. Oh. Append as. Oh, look there. Infix R. Okay. But this is just binary functions. Okay, so I would probably go like, so let's define a new function called plus plus. And I would say plus plus. Yeah, it takes two ints and it returns. Okay, so ignoring the fact that we got plus already, but that's fine. And then it looks like I can go infix R5, append as that. What is the 5? I don't know.
What is the
Infix
not
R
equal to at the end?
plus plus as plus plus. Yeah, no, I think that is what the new symbol is going to look like. So he's defining what, yeah, I know you think this looks like not equals to, but we saw it earlier on where we wanted to append strings. So it's the operator for append, actually.
Oh, I see. Yeah, I missed that part. Okay, cool.
So they're saying infix R5 append. So here's the function for list and a list and a list. This is going to append lists. This is how it appends them. Why 5 though? I don't understand the 5. Yeah, so obviously infix operators must only have 2 parameters and return a parameter. Like it's not possible that it does anything else, right? Because infix only has a left and a right, and it returns one thing, right? So that makes sense. So it must always be of the form A to B to C. I don't know what the 5 is. So let's try it. Infix 5. Oh, it could be the precedence. So it could be that's the precedence. Ah, yes, the precedence. An integer between 0 and 9. Here it is 5, right? So you know what operator precedence is? Yeah? Or no?
It's priority.
Yeah, exactly. So it's like saying if I've got so here we've just defined a new function called plus plus. So we can go, cool, y equals 1 plus plus 10. Check it, like works. And it's like, oh, y is, does it work? This thing, oh yeah, we've got that funny modular problem there. Isn't like this. Yeah, so it's saying y is, the inferred type was an int. Yeah, so it's saying it's an int, y is an int, which we're happy with. The 5, from a precedence perspective, it's interesting because I could have gone y plus plus equals 10, minus 20 multiplied by 50 or something, and that would be okay. And it's just like mathematically, the precedence tells you in what order it must resolve these operators, right? So it must bracket them. So probably the lower the precedence, so if it's 0, then it would tend to do this part first. Whereas if it's a higher precedence, it would tend to do that part first. Do you know what I mean? So it's just a way of resolving the maths, the bod maths, which is really cool. So it means like you can change the precedence of what plus does, right? By defining a new one and change its precedence. Like pretty interesting, actually. I mean, it's pretty powerful, but pretty batty as well. So however, oh yeah, so the point was that I wanted to get to when we were trying to solve our modulo thing here is we can't just go mod there because it can't be e mod 2. It's probably mod as a function that takes 2 parameters, right? E and 2. Does that make sense? Because
that would make sense.
I mean, there could be a mod operator. However, what you can normally do is any function that suits this kind of layout, you can backtick stuff. So I could still call plus plus by going like this, plus plus, and put backticks around it, which will convert it to an infix function. That's a Haskell thing. You can absolutely do that. So the better way to write this would still be with mod, but you backtick the mod, and then it converts it into an infix function.
Makes it a bit more readable.
Yeah, as long as mod takes 2 inputs and 1 output, you can backtick it and it'll convert it into an infix, which is pretty cool, especially in a case like this, because going like mod E2, like that doesn't read to me as well as E mod 2.
E mod 2.
Right? Yeah. And you might find that, I mean, so actually we could just say infix are, I don't know what the precedence is, naught mod to a percent, as percent, and we probably could just put our percent here. Hey, how cool is that? So here we have just said, fuck it, we want to use percent because we're happy with percent, and so we've just like defined it mod as percent. It doesn't like X because of some earlier reason probably. That makes sense.
Yeah.
Potent, hey? How potent?
Very cool.
Yeah. So I think, should we stop there?
I think so.
You happy, Matt?
Yeah. Yeah,
Okay,
I think so.
Guys, have a good day.
Cool. Thanks, Tom.
Awesome. Thanks, Tom.
Dudes. Speak to you later.
Cheers.
Cheers.